Good morning and good afternoon to all of our participants in Taiwan and India. I am Jason Wang from TISFA, Taiwan Surface Finish Association, and also the host for today's online meeting. Okay, perhaps we can make a start. Thank you all for coming to 2021 Taiwan-India Surface Treatment Industry Online Green and Sustainable Technology Forum. Let's start the meeting by welcoming our distinguished guests from Taiwan. First, please welcome Chairman of Taiwan Surface Finish Association, Dr. Austin Xu, to give us welcome remarks. Hello, Mr. Xu.
Hello, Alex. Good afternoon, everyone. The COVID-19 cannot separate us. Only through cooperation, we can generate great benefit to each other. Today is a milestone not only for TISFA, but also for the whole. We cherish the new relationship with EMFA. We look forward to more cooperation. Thank you.
Thank you, Dr. Xu, for the welcome remarks. And next, please welcome our Deputy Director of Metal Industries Research Development Center, Dr. Yongzhen Wu. Hello, Dr. Wu.
Hello, everyone.
Next, please welcome Deputy Director of Industrial Technology Research Institute, Dr. Stephen Zheng. Mr. Zheng.
Hello, everyone.
Next, please welcome Division Director of CNFI from Taiwan, Mrs. Phoebe Chen. Hello, Mrs. Chen.
Good afternoon, everyone.
Okay, thank you to our distinguished guests. Now, we are very delighted to hand over to India and invite Chairperson of Taiwan Chamber of Commerce, Mrs. Jennifer Makecha, to give us welcome remarks. Hello, Mrs. Makecha.
Hello, can you hear me? Hello? Hello?
Hello, Jennifer.
Yes, hi. Good morning. Good morning, Dr. Stephen Zheng, Dr. William Zheng, Dr. Austin Xu, and Phoebe. I think today I've seen you, Phoebe, and also Mr. Sanjay Gurani from India. Yeah. My name is, my Taiwan name is Zhen Xiaoli, also known as Jennifer Makeja in India. I have been the chairperson of Taiwan Chamber of Commerce, Mumbai, since the year 2015. Since last year, I was also being appointed and certified by Taiwan Minister of Affairs Council as the Associate Advisor in India. I am a Taiwanese man. Can you hear me? This little disturbance are there. I'm a Taiwanese, married to Indian in the year 2011. 2004. So after staying so many years in India, I've been pretty much an Indian now. Okay, so I have experienced the major changes in living standard in India and also witnessed the rapid growth of economy in India. India is the second largest manufacturing hub in the world now, and I believe the Made in India policy initiative by the Indian government can definitely help equip India to become the next world factory. And Taiwan is predominantly an export-oriented economy and has established a robust global supply chain in the world. And Taiwan company has played an important role in seeding the coastal of China and Southeast Asia countries with the manufacturing capabilities. So Taiwan is a very powerful anchor to these countries during the early days of, contribute to the early days of investment and global production lines. So I would say Taiwan's experience, manufacturing capabilities, skills, and investment has driven these countries during their early days of reform. So similarly, if we follow the same model, there's no doubt that Taiwan can be the same powerful anchor to India by close collaboration. So Taiwan is a logical partner for India, Made in India initiative by the Indian government, and can contribute to the Atmanirbhar Bharat. Taiwan Chamber of Commerce was established in the year 2011 as a non-profit organization. We have till today around 30 members of 30 companies into different industries like chemical, electronics, machinery, energy, computer, etc. And the mission of TCCM is to consolidate the strength and experience of Taiwanese business communities in India, to bridge the gap between the mainstream business groups and to help enhance the position of Taiwan Indian businesses. We have been achieving this by promoting the exchange of information and to collaborate with the local chambers. And our role is to be as the representative of Taiwanese business community within the local chambers, municipals, state, central governments, and of course with the Taiwan government. Today, I'm very happy. It's my honor to be here to help connect both India and Taiwan into this surface finishing industry. Finally, I would like to give my special thanks to Mr. Sanjay Kukani, the president of AMFA, who has approached me and initiated this wonderful opportunity to building up the understanding and the collaboration between Taiwan and India surface industries. And of course, I would like to appreciate Dr. Austin to give the full support of this program. Thank you very much.
Okay, thank you, Mrs. Jennifer Makecha, for the very warm welcome remarks. And next, let's welcome Deputy Director of Industrial Technology Research Institute, Dr. Stephen Zhen, to give us welcome remarks. Hello, Dr. Zhen.
Okay, Mr. Jennifer Makecha, and the Chairman of the TCCM, Dr. Austin Xu, the Chairman of the TSFA, Mr. Sanjay Kukani, President of the AMFA, Mr. Bobby Chen's Division Director of CNFI Taiwan, and Dr. Yongchen Wu, Deputy Director of the MRDC, and all our guests from Taiwan and the Indians online. Good morning and good afternoon. I'm Stephen Zhen, Deputy Director of the E-Trees. It's my pleasure to be invited today, and also thanks the main organizer of this event, Taiwan Surface Finishing Association and the Association of the Metal. Taiwan government has implemented new southbound policy since 2016. We have witnessed a lot of progress in these years, and also expect more cooperation of the bilateral investment and the industries cooperation in the future. I think it's the first time to hold a green technology forum surface finishing industry. Also connect to the sustainability issues, which protection. I hope all participants, specialists, and the companies who attended today's forum in India can receive the very excellent speakers and create more cooperation opportunity for your business. I wish the great successful on this forum, and this COVID-19 pandemic could be end soon. Thanks for your participation today, and thank you all.
Okay, thank you, Dr. Chen. And next, please welcome Deputy Director of Metal Industries Research Development Center, Dr. Yongcheng Wu. Hello, Dr. Wu.
Hello, everyone. Good afternoon and good morning in India. Chairman Austin, Xu, and Jennifer, and honored guests, friends from the industry, both in Taiwan and India. I am Yongcheng Wu. I'm very grateful to attend this meeting, and as everyone knows that in recent years, Taiwan are moving into a high value-added manufacturing domain. The importance of raising the surface finishing technology cannot be understated. And surface finishing technology is an essential and important technology to improve a product's feature and to achieve a desired appearance. In recent years, MIRDC has been exploring AI-assisted development possibilities for surface finishing. For example, we have developed AI-assisted prediction technologies such as the thickness and the processing time for electroless nickel plating and electropolishing processing time and additive amount. In addition to AI development, MIRDC will continue to develop new technologies for metal industry related, also for surface finishing industries. And we try to cooperate with association to connect more companies and solution providers to create an environment that can be an advantage development for the surface finishing industries. Finally, I would like to extend my sincere wishes to this forum that to bring the best result. Thank you.
Okay, thank you, Dr. Wu. And next, we are very delighted to hand over to India. Please welcome the President of Association of Metal Finishers from Aurangabad. Okay, now we are moving to the next session. Before starting the topic, let's take a short break. We'll be right back. Hello everyone, welcome back. Let's continue our welcome remarks. Please welcome President of Association of Metal Finishers, Aurangabad, Mr. Sanjay Kulkarni, to give us welcome remarks. Hello, Mr. Kulkarni.
Hello. Good morning, everyone.
Hello, Mr. Kulkarni.
Hello.
Hello, please give us welcome remarks.
Yeah. Good morning. Good morning, sir. On behalf of our association, Metal Finisher Association Aurangabad, I welcome all of you, all my members, and Metal Finisher Association from Rajkot, Gujarat. I personally thank Ms. Jennifer Madam, Dr. Nasu, and all their team present in Taiwan and Mumbai for their wonderful contribution to make it happen. This seminar on surface treatment with Taiwan Association. I request Ms. Rahul to present our presentation for this session. Thank you.
Okay, thank you for the welcome remarks. And now we are moving to the next topic session. Coming up is our first topic. Please welcome Mr. Rao Agrawal, CEO of Krishna Engineering, to share with us about India's surface finishing industry introduction. Hello, Mr. Agrawal.
Hello. Good morning, everyone. Thank you for giving me this opportunity to present my association to Taiwan Association.
Oh, hello, Mr. Agrawal. You can start your presentation right now. Please share your introduction with us. Hello, Mr. Agrawal. Can you hear us? Are you ready with your presentation now or not yet?
Aurangabad is a world-famous historical city of India which has two UNESCO-approved sites, Ajanta and Ellora, in close proximity. The city is home to over 1.2 million people. The city is well connected by road, rail and air to major industrial towns across India. The city offers high-quality education. Thousands of skilled employees who make up the pulse of thriving businesses are provided by the leading engineering colleges and training institutes run by the central and state governments as well as private institutions. The growth in the industrial sector in Aurangabad started in the mid-80s. It has continued till today, showing no signs of slowing down, with the prestigious DMIC project coming up in the Shendra-Bidkin industrial area, which has a land bank of over 10,000 acres. Thus, this is the ideal place to invest in, with the best of infrastructure maintaining a balance between nature and industries. Today, this city is home to automobile sector giants and many well-known brands from the auto component sector. The supply chain is very well established with all Tier 1, 2 and 3 vendors keeping up with the best of industry trends and benchmarking, which helps them stay competitive. Almost all automobiles built in India have had some contribution from Aurangabad. The city is also host to well-known brands in the related supporting sectors like machines, SPMs, tools, gauges, fixtures and work holdings, etc. Aurangabad is also home to many leading pharmaceutical companies, breweries, plastics, seeds, foods and consumer durables, along with new entrants in the field of IT and electronics.
Now we move towards our association. Welcome once again to the next presentation. Welcome once again to the next presentation.
Okay, thank you, Mr. Alcohol.
This is a very historical moment for the Taiwan industries and also for the Aurangabad Metal Finishers Association. Thank you to Jennifer Mayer to bringing this both the association on one platform. Next slide. Organized by Association of Metal Finisher Aurangabad, India, Taiwan Surface Finishing Association, and co-organized by Taiwan Surface of Commerce Mumbai and Industrial Technology Research Institute and CNFI. Association of Metal Finishers has formed in 2017. We have 45 active members in our fitting industries as well as traders. These are some of the tips of the metal finisher. Apart from the regular installations, we have done several projects. Like ETP plant in several, visit to ETP plant in several, that is near Pune. Visit to Growell R&D Center. Growell is a well-known company called where we have got a manufacturing unit for the chemicals. So they have allowed to visit their labs. We have done 106 tree plantations near our villages. Technical seminar by Growell, where we learn what next and what in future we can do in chemical industries. And also in this pandemic situation, we have contributed some of the handsome amount for the relief persons. This is some of the movement for our first installation. Our ETP plant visit to a Sherwal in Pune. A visit to a Growell R&D Center. Tree plantation near our village. technical seminar by Growell India. Now, this is our metal finisher industry in Aurangabad. As we have 45 active members in our industry, in our Aurangabad industries, and these are the plating facilities which we have in our Aurangabad. That is acid zinc, alkaline zinc, nickel chrome, hard chrome, zinc nickel, copper, tin, silver, and many others. These are some of the upcoming events which we have planned in future. That is again a technical seminar by the Arctic Surface Chemicals, technical seminar by Fisher Measurement Technologies, and also a visit to a Taiwan for electric industry. Actually, this was planned in May and June itself, but due to pandemic situation, it has been cancelled. Thank you, everyone. See you soon in Taiwan.
Okay, thank you for the presentation. To let us have a brief look at India's surface finishing industry. And next, let's welcome Dr. Austin Xu, Chairman of TISFA, to share with us about Taiwan surface finishing industry introduction. Welcome, Dr. Xu.
Hello, good morning, Jennifer and my friend from ENFA, and all the audience here and on the internet. Okay, please allow me for 15 minutes to give you a brief presentation of TISFA in Taiwan. Okay. Okay, today I will focus on the following 4 aspects. The first one is I will introduce the role of TISFA and the current status of our industry, and the key issues we are facing, and the future plan and the strategy we plan to do. TISFA was founded in 1988. It's almost been 32 years. However, our industry began far more earlier than that. It's the service industry in Taiwan, we can say is almost 100 years. Currently, we have 300 members around Taiwan, and it's about 35% located in the north, about 40% located in the central of Taiwan, and about 25% in the south. And because of the geographical factors, on the East Coast, we mainly have only agriculture and tourism industry. And here is our organization. This is a nationwide association. We have 4 offices around the island in order to provide service to our members and to communicate between members, industry, and government. Our vision is to help our industry to become one of the top leaders in process and material application in surface treatment technology. And this will be beneficial to all the human and environment. Our mission is to support our industry to grow and improve continuously and help to become the best service provider to the world. I will summarize as our TISFA's role in this slide. You can see that the interaction among members and TISFA and the government. And we provide service to our members and support them to promote their technology or business. And we organize exhibition, forums, and education programs. And every year we collect consensus of the industry to provide to government for their policy decision. So this is the main role of our TISFA. Next, I will brief the current status of our surface finishing industry in Taiwan. Okay, first, the average revenue of the surface finishing industry is about 30 billion NT every year. And around the island, the total employee engaged in this industry is about 1,400. Okay. No, it's about 3,137, I think. Okay, and we have total 1,400 shops around Taiwan. And most of our members, they provide process to their customer. And this is, we call process value added service. And all the customers directly from Taiwan. So it's about 90% of the customer from domestic. And from the scope point of view, most of the plating shop is small or medium operation. And from what kind of plating content category, we can see that almost 50% the service is for electric plating, and it's about 17% we focus on surface coating, either spray coating or powder coating. Okay. And it's about 13% we provide hot heat treatment service to like hand tool or special machine tool or machine parts. And it's about 19% we focus on optical service. Okay, this is the current service finishing category in Taiwan. And related to previous slide, the customer category, we can separate, we can list the revenue from the top to the end. You can see that the first revenue, largest revenue comes from the hand tool and electronics. Okay, if this is very valuable reference from research institute. If you need to have this kind of information, we can provide to EMFA. Okay, we summarize the features of Taiwan service finishing industry as the following. The first feature we can describe as most of the operation is small or medium. And most of the shop plater, they provide only service without the integrate complete product. And when we visit the plating shop, we can find that all the engineering, that they are very skillful in providing what kind of customer demand. And so when customer comes to the plating shop, the engineer always can design and rearrange the plating parameters or manufacture different kind of plating machine to meet the customer requests. And for most of the service finishing, we can say that it's about 50% of the service is related to electric plating process. And the last one is that most of the service finishing plating shop, they need to provide immediate service to their customer. So there is clustering effect. So they always gather with the electronics industry area. So in the north of Taiwan, we focused on electronic industry. And in the central of Taiwan, most of the plating shop, they provide service to high-end tooling machine or optical industry. In the south of Taiwan, most of our plating shop, they provide service to machine tool or some exercise equipment. And this slide shows that the current problem of our service industry. The green line represents the shop with more than 100 employees. And the red line represents the plating shop with less than 100 employees. And you can say that employee age differentiation, most of the employees, they age between like 40 to 50. So the engineering age become older and older. That is the problem we are facing right now current in Taiwan. The manpower shortage. So the next slide, I will list out the problems we are facing. Focus on three categories: the environment issue, and technology improvement issue, and the competition issues. Because maybe you cannot see the slide very clear, but I will summarize very short that because of we are facing the very harsh environment law requirement, so we need to improve our plating control, and also we need to reduce the plating waste significantly. And in this way that we may pay more cost on the environment waste treatment. And when we facing about the technology improvement issues, that most of our plating shop, they are either with old generation to rely on old generation to operate the factory, or they are with very old environment or old machine, and they need to pay more cost for a new machine, and they need to learn the modern management to help them to improve the quality. Okay. And third category, the problem we are facing is that the employee become older, and no young generation like to engage in this industry, and they lack the opportunity to join research, high-end research activity. So currently TISFA is helping them to cope with all the challenges. So among the challenges I just mentioned in the previous slide, we are in a new stage of changing. So we are getting help from government, such as MIRTC and other specialists, to help our industry to implement more intelligent management for surface treatment industry. In this slide, you can see the green tech that we start to build new modules for each process. And in the future, about 2 or 3 years, we will integrate all the future from pre-treatment and inline process and waste treatment, and will become totally AI manufacturing service treatment technology. And we will provide this kind of integration service to our members in the future. Okay. The last slide is that this is a very special Taiwan species. We call it Taiwan blue vampire. So I swear to you that as you just mentioned, that we look forward to green and safe and high quality plating environment. And our members not only spend money and effort to improve their manufacturing quality, but also they spare no effort to protect the environment as you. So I really cherish our new relationship with EMFA. I believe we can work together to achieve these new goals. Thank you very much.
Okay, thank you, Dr. Shi. Thanks for the very informative sharing. And next is a video from Mr. Brendan Lloyd. He's a General Product Manager of Atotech. He will share with us about sustainable cleaning and degreasing.
Hello, everyone. I hope you are all doing well and staying healthy. First, I would like to thank both TSFA and AMFA for offering us this platform to share about some of our technologies at Atotech. With the limitations that we've all experienced this year in travel, it's greatly appreciated to still be able to reach all of you in this virtual manner today. I'm excited to share with you today about our family of long life, low temperature cleaners and degreasers, otherwise known as UniPrep. So our UniPrep processes have been in use for approximately 20 years, mostly in pre-paint applications, but within the past 5 to 10 years has seen considerable growth in plating applications. In this webinar, I plan on highlighting the many associated process benefits of UniPrep processes. So thank you again, and I hope you enjoy the presentation. So today on the agenda, we'll discuss 4 primary topics. The first being improvements to conventional degreasing. Secondly, we'll discuss some of the economics of sustainable cleaning processes. Then we'll go over a few case studies. And then lastly, we'll summarize. So to start, let's first focus on the importance of cleaning. So cleaning is really the essential first step for all pre-paint and plating processes. So improper or incomplete substrate cleaning can result in some of the following issues: visual defects such as cratering, blisters, hazing or non-uniform appearance, again, whether we're considering painted parts or plated parts. Poor adhesion, this can be through crosshatch, impact, boiling water, mar scratch tests, or any other number of tests as well. Can also result in poor corrosion resistance. Here we consider normal tests like salt spray, whether it's NSS or CASS, cyclic corrosion evaluations, and filiform tests. And these rejects lead to costly rework and production inefficiencies. So some of the process concerns and disadvantages of conventional degreasing methods. So conventional alkaline cleaners are capable of removing many organic soils, but have several associated disadvantages, including the following. So they typically operate at high operating temperatures, somewhere between 55 to 80 degrees Celsius. What comes with that is a high associated energy cost. Additionally, it can have a high associated carbon footprint. The solution life is often relatively short, and sometimes they will use restricted or regulated substances like phosphorus, boron, nonylphenol, and octophenol ethoxylates. And all of these substances are ones that have seen increasing regulation over the past few years, specifically in the EU, but we're starting to see a lot more around the world as well. So as the organic soils are removed from the substrate surface, they become emulsified in solution, leading to the gradual decrease in cleaning performance until the solution must be replaced. So now we'll talk about some of the improvements to conventional degreasing methods that are available today. So Atotech's approach to improving conventional degreasing methods really comes down to two important factors, long life and low temperature. First, we'll focus on long life aspects. So some of the advantages that this offers is a stable cleaning performance throughout the usable life of the cleaner, and less frequent cleaner makeups, which have several associated advantages with it. So there's chemical savings, reduction in waste, labor savings, meaning that there's less maintenance required, and so less time is dedicated to the tank dumps and maintenance of the system itself, and then an increase in overall plant productivity. Now, if we focus on the low temperature aspects, one of the primary benefits, of course, is energy savings. There's also the reduction in emissions. And then lastly, it's offering a safer work environment for employees, especially when we're considering chemistry that is using less regulated substances and also operating at lower temperatures. So, process description of Uniprep long life, low temperature cleaners. So long life, low temperature cleaning is achieved by so the Uniprep cleaners are specifically formulated to function at low operating temperatures. The part is degreased utilizing a cleaner with a highly emulsifying surfactant system. What then happens is these emulsified oils are degraded in situ, meaning inside the cleaner system itself. The surfactant molecules that have helped emulsify the oils are then made available to emulsify additional oil introduced through the cleaning process, resulting in this long life cleaning system. So the degradation of the emulsified oils occurs continuously over time and is really one of the unique advantages of Uniprep long life, low temperature cleaners. Uniprep cleaners were initially developed for pre-paint applications, but have been successfully implemented by plating applicators globally, offering some of the same process advantages as those achieved in pre-paint applications. So Atotech's Uniprep cleaner portfolio offers applicators superior process versatility. So these specialized cleaners were developed for both spray and/or immersion applications. The immersion cleaners are suitable for pre-paint as well as barrel and rack plating applications. And then if we consider our spray cleaners, they're offering high-performing and low-foaming solutions for pre-paint and plating applications. And if we look specifically at the plating applications that would require spray cleaners, we consider systems like continuous screw, rotating drum, belt washers, and any other number of spray systems utilized by plating applicators today. So now we'll focus on some of the process benefits. So the low operating temperatures result in substantial energy savings. In some of the following slides, we'll discuss some of the economics of this. The long life benefits of UniPrep cleaners and degreasers include increased productivity, waste treatment savings, reduction in COD and FOG, which is important for wastewater treatment operations and effluent, chemical consumption and cost savings. And we typically see in greater than 98% of our applications that the UniPrep cleaners are able to achieve a 2 times bath life extension in comparison to conventional cleaning. However, many of our customers have realized a 3-time or 4-time increase in cleaner life compared to conventional cleaners, and sometimes even more, which we'll discuss a little bit later. Lastly, it's supporting the maintenance of stable performance throughout the cleaner life, providing consistent results while minimizing the possibility for part rejects. So if we consider a conventional cleaner, the performance decreases as a function of the emulsified oil content in the solution. So if we look at the diagram at the bottom of the slide, you can see that over time, and as the amount of oil increases, the cleaning performance will gradually decrease, finally to a point where you must dump the cleaner and replace it. And then what then happens is the cycle is just replicated over and over. If we consider UniPrep long life low temperature cleaners, the performance is going to remain consistent throughout the cleaner life due to the degradation of emulsified oils. Of course, there will be some gradual decrease as the oil content starts to increase slightly in the cleaning solution, but what we see typically is the cleaning performance is quite stable throughout the entire usable life. So we have, in the past, we've conducted controlled laboratory experiments to exhibit how the oil levels can be reduced by as much as 7 times in our UniPrep cleaners. So if we look at the diagram, the image on the left, we can see 2 graduated cylinders. The one on the left is a conventional cleaner, and you can see the oil that has separated out from the cleaner itself. And for the UniPrep cleaner, the graduated cylinder on the right, you can see that the amount of oil is significantly decreased. Another way to visually see this is with the 2 images on the right side of the page. So the conventional cleaner, you can see the oil sitting on the surface of the cleaner tank itself. And with the UniPrep cleaner, you can see that the amount of oil is significantly reduced compared to the conventional cleaner. So now we'll discuss some cleaning quantification tools. So a key component of long life, low temperature cleaning is really being able to quantify that adequate substrate cleanliness is being achieved, both prior to and after implementation of the process in production. So there's several simplistic methods like white glove or white tissue tests, as well as water plate tests that can give you some indication of substrate cleanliness. You know, some images, the images on the right side of the slide here exhibit these specific tests. So if we consider some of the advantages of these tests, first of all, they're non-destructive, so it can be conducted on production parts. They're very easy to conduct, and they're relatively inexpensive as well. The disadvantages, however, are that the results cannot be quantified. It's really only a visual inspection. They are dependent on the inspection quality and the inspection personnel skill. And for certain pre-paint and plating applications, a more sophisticated evaluation is really required to ensure that the subsequent coating is not compromised. So if we could consider going back to the first slide where we talked about the importance of cleaning, you know, this is really the key first step in ensuring your final part quality. So some of the more sophisticated methods that exist are aiding in the cleaning quantification better than the previously mentioned conventional methods. So we have 3 specific methods that we consider within Atotech as we evaluate cleaners and degreasers. The first is auto deposition copper immersion. So this is very easy to conduct and provides a very good comparative result for the evaluations. However, it can be a little bit difficult to quantify the results and is only suitable for steel components. So if you look on the right side of the page, you can see the first two images at the top are exhibiting the auto deposition copper immersion test. The first part on the left is showing pore cleaning, and typically how this is visually seen is poor part coverage, or poor copper coverage on the part itself, and a dull finish. So if you look at the image on the right, we can see that this is significantly improved. We have a bright uniform copper deposition on the steel part, and there's no voids in the coating itself. Another method is surface tension fluids. These are suitable for multiple substrates and provide a quantifiable result. This does require some skill to conduct the test, but does become quite easy after some training. So the bottom image on the right side of the slide is showing a part that has been cleaned or degreased and is evaluated at 3 different surface tension fluids. The first one being at 40 dyne per centimeter, the second being at 50 dyne per centimeter. Here we can see that the solution is completely wetting out and is considered a passing result. For the 60 dyne per centimeter, this is an NG. We can see that the surface tension fluid is pulling back on itself and not completely wetting out on the surface. Lastly, there are specialized surface analysis equipment that are available on the market today. So these are suitable for multiple substrates. They do provide a quantifiable result, and one of the key components to this is it's a non-destructive test. So it can be done on the production parts immediately on the line. But because this is a specialized equipment, it can be quite expensive and requires operator training in order to function the system properly. So when we're considering the cleaning quantifications, customers need to utilize continuous cleaning checks to evaluate the substrate cleanliness, and this can be utilized to determine when a cleaner process stage should be changed. So this is very important when we're considering long life cleaning, because if we're going to extend the bath life, we need to ensure that the cleanliness is at an optimal level throughout the usable life. So one applicator that has of Atotech that has implemented the surface tension fluid tests did this test continuously over a 15-week period. And what they realized was that at a certain point, when the surface tension was starting to decrease, they saw quite a big increase in the reject rates that they were having on their finished parts. So what they were able to establish then is that at a value of 55 dyne per centimeter, this is where they wanted to dump their cleaner and remake in order to minimize the amount of rejects they would achieve. Now let's talk about some of the economics of sustainable cleaning processes. So if we consider a conventional degreaser versus Uniprep long life, low temperature cleaning, and in this application specifically, we're going to focus on a spray cleaning application for pre-paint. So the customer is utilizing a 20,000 liter degreasing tank, utilizing a natural gas boiler for heating the process stage. And their production volume is approximately 750,000 square meters per month. So the conventional degreaser, if we consider some of the parameters for it, we would say that the unit cost is X US dollars per kg, operated at 5% concentration, 55 degrees Celsius, and typically would have about a 20-day bath life. If we consider the Uniprep cleaner, this has a slightly higher unit cost at 1.5x US dollars per kg, but is operated at 3% in comparison to the 5%, 20 degrees Celsius lower at 35 degrees Celsius, and we can see that the bath life is going from 20 days up to 120 days, quite a big extension. So if we consider some of the overall process benefits from this, first we'll focus on the chemical cost. So if you look at the conventional degreaser, we can see that the overall annual cost is about $200,000 per year. If we consider the UniPrep cleaning process, this cost is only about $189,000 per year. So in total, this is offering a 5% savings. And this is still in consideration of the fact that the UniPrep cleaner is at a higher unit cost. So the energy cost, we can see with the conventional degreaser has a cost of about $220,000 per year, while the UniPrep process is only at $100,000 per year. The total savings here is 56%. Lastly, if we consider the running cost, with the conventional degreaser, it's around 5 US cents per square meter. And with the UniPrep process, it's only about 3.5 US cents per square meter. So the total running cost savings is about 32%. But that does not summarize all of the total process benefits that can be achieved with the UniPrep cleaner. So we can see that the spent chemical is reduced from 260,000 liters down to 80,000 liters per year, total savings of 180,000 liters. And then if we look at the CO2 emissions, this is reduced from 936 metric tons down to 420 metric tons. Again, a 55% reduction. So here we can see the overall benefits that the UniPrep processes can offer to applicators. So lastly, we'll go over some case studies. So case study 1 is an existing Atotech customer that has implemented UniPrep long life, low temperature cleaners into each of their 4 lines. So the primary benefits that they were looking to achieve were reduction in overall chemical consumption, process improvements in final part quality, and sustainability initiatives. So with UniPrep implementation, they were able to significantly increase the bath life. We can see that in almost every instance, we were able to increase it by 2x. The total number of cleaner makeups that we eliminated annually was 14. So in summary, there we have 128% cleaner life extension for all of the lines combined, and an 18% reduction in the daily cleaner replenishments. So this is quite a big benefit here in supporting reduced overall operating costs. So if we look in summary at the total benefits, from the cleaner dumps itself, the customer was able to achieve about 28,000 US per year in savings. The daily cleaner replenishments reduced the overall cost by almost 200,000 US per year. The additional benefits that they achieved were through energy savings, almost 45,000 US per year. Reduction in the labor was attributed to 10,000 US per year. The CO2 emissions was greater than 440 metric tons reduced per year. And then filter cleaning is also one of the key benefits, reducing this by 65%. So the total annual savings achieved through this customer was greater than 270,000 US dollars. So another case study I want to discuss today is an automotive fastener manufacturer producing about 10,000 kilograms of parts per day. So they were seeking a longer life and ambient temperature solution to replace their existing conventional degreaser. The process benefits achieved with implementation of UniPrep in this case were extended solution life by about 2.5 times, reduced cleaner concentration from 10% to 7%. They eliminated the necessity of heat for cleaning solution, reducing the temperatures from 60 degrees C down to 35 degrees Celsius. And then lastly, they were able to reduce the chemical consumption from 5 grams per square meter to 2 grams per square meter, saving almost 9,000 kgs of cleaner concentrate annually. Lastly, we'd just like to highlight some of the other applications that we have seen globally in plating with a significant improvement in the bath life with implementation of UniPrep cleaners. So if we look at the table here, we can see many different examples. So that again, the first one we see an alkaline zinc nickel rack plating applicator that is able to extend their bath life by 4x. We see the third instance, which is an electroless nickel rack plating application with a much smaller tank volume, that was able to achieve at least 2x. And this is possible to extend even further because this installation only took place within the last year. And then the last one we'll discuss here is the acid zinc rack plating application. You can see with a tank volume of 5 cubic meters. And what we're able to achieve here is a 20x bath life extension. So we can see that in every application, it can be quite different what the UniPrep offer to the customer. So these customers, as a collective, which are serving multiple industries, including automotive, fasteners, and general industry, have attributed many savings and process improvements with the implementation of UniPrep, including less rejects, longer bath life in comparison to other chemical stages. So in summary, long life, low temperature cleaning processes can increase the overall sustainability of the pretreatment process. It's offering lower operating temperatures, longer solution life, increased total process savings, and stable operating conditions. As a collective, UniPrep is demonstrating that Atotech's continuous drive to develop and introduce highly sustainable processes for the surface finishing industry, addressing many of the concerns that are typically associated with conventional processes. So, in summary, thank you to all of you, and I want to say thank you again to TSFA and AMFA organizations for allowing this opportunity today.
Effective solution, metal waste recovery. Hello, Mr. Hong.
Hi, thank you. Good afternoon, everyone. Today, I'm very proud to be invited here to share this topic about the cost-effective solution of metal waste recovery. And to begin with, today we're talking about two topics. First one is about metal waste recovery in plating industry. And then I will present you about our system of nickel recycling. So in the past, many plating shops, they are thinking the wastewater are unavailable. But in fact, there are many different types of metal content in wastewater. And it can be either recovered or recycled. But only a few plating shops, they are doing metal recovery, especially for precious metal plating or in PCB industry. And this metal recovery is not really a popular topic in general plating. But with the rise of environmental awareness and in recent years, environmental protection law has become more and more strict, and it leads to the wastewater treatment costs become very higher. So many plating shops start to think maybe we should get metal recovered, especially for the wastewater treatment. So today I just will go over just quick for most common method to recover metal. And there are 5 types to recover metal most commonly can be used in plating industry. The first one is evaporation and condensation. This is it's like a simple way just by heating up temperature and increase the pressure to retrieve the metal. But this is not very cost effective because it's spent a lot of money and it's very energy consumed. And the second one is electrolytic type process. It's basically to electrolyte the wastewater or water or metal content water to retrieve metal. And the third one is electrodeposition. It's more like electroplating process. It's to plate or deposit the metal on certain subject. to get the metal. And the fourth one is the rinsing. And here we are talking about is ion exchange rinsing. So here is to use rinsing to catch certain or your target metal and then turn it into a liquid form and get back to use in your plating line. And the final one is the membrane film. And this one is mainly to recycle water first. And then you can get a metal concentrate and then get back used in your plating line. So these 5 are most popular common way you can use in plating shop. And then I'll go over our own system about recovering nickel. And our system is using ion exchange rinsing. And we choose these technologies because we want to selectively to recover nickel from plating line. And also we can recover recycle the water back to the line to use. So we start to think either we can treat the wastewater or we can find a source from the wastewater. So we choose to treat the rinsing water after the nickel tank. So we can get the nickel back into nickel sulfate solution. So we can get about 99% of nickel recycled as nickel sulfate solution. And then about 80, and because nickel can be isolated, so water can also be recycled. About 85% of water can be recycled and back to the line. So it can and it also can decrease the wastewater discharge. And here, because we use ion exchange, so I just briefly explain the mechanism. Here we select special rinsing, which have very high selectivity to nickel. So first, there are 3 reactions. The first, we call it adsorb. So adsorb is to absorb we use a sodium type of rinsing to absorb nickel, and then get the nickel type rinsing. And then we use sulfuric acid to go over rinsing and then get the nickel sulfate solution. And the third reaction is to turn the rinsing back into its original form. So we call it a regeneration. So we use sodium hydroxide to replace the hydrogen and get the rinsing back to its original sodium form, sodium type. And the next page will just show you the graphic, so it get you easy to understand how this mechanism works and how we design this process. So the first, this you can see is the column filling of the sodium type of rinsing. And then the nickel content, the rinsing water will go through the column and nickel will start to be absorbed. And in the second column, and then the second picture is to show you when nickel is fully absorbed. And then we could do the sulfuric acid to do the transformation to get the nickel sulfate solution. And then the final one is to replace the hydrogen with sodium and get the rinsing back to its original type. So this rinsing can be again used to absorb the nickel again. So we don't need to abandon or replace the rinsing. And this final page is to show you how this nickel recycle system works with the plating line. So usually after nickel tank, we usually have one recant tank to get the nickel plating solution. And then parts will go over into 3 rinsing tank. And rinsing water will, the fresh rinsing water will go from the tank 3, rinsing tank 3, and then overflow to tank 2 and then to tank 1. So inside the tank 1, the water contains high concentrate of nickel. And this high concentrate nickel water, nickel rinsing water will goes to our system for nickel recovery process. And here we have the 3 cottage, or you can say the 3 column of the rinsing. Why we want to design 3 column? Because we want to the plating shot can do plating and nickel recovery at the same time. So we call it, it's like an online process. So we don't need to do the offline process, which means plating line must be stopped and then you do the recycle. So if you need to stop the plating line and then do the recycle, means this is not cost effective. It's not really good option. So we will go over the rinsing water, we'll go over the cottage A and then go to the B and then go to C. And of course, the cottage A will be the first one to be fully absorbed of nickel. And then nickel, and the system will switch the water flow to the B and then goes to C. And then cottage A will just separate nickel and then go over turn into a nickel sulfate solution, and then go over the regeneration to its original type. And the water flow is go over from B, C, and then to A. And then once again, B will be full, and doing the process again, and flow will go to C, A, then B, and go on and go on. So as a result, we can get nickel sulfate solution and then water recycle. On the left-hand side, we have the nickel sulfate solution, which you can use back to plating line. Usually, we put into a semi-bright nickel tank. On the right-hand side, we have water can recycle, can either use back to your plating line. Usually, use back to your plating line. And some plating job will use back to rinsing water, or you can use back to make up the cleaner or make up for post-treatment, and about 15% of water for discharge. And here our performance for this equipment is we can get very good quality of the nickel sulfate solution, about 260 gram per liter of concentration. So it's almost like a ready to use. And then water, it's good quality and can use back to either to your rinsing water or for makeup for cleaner. And also for wastewater, you can have very low content of nickel. For a few of our customers, we measure their nickel content in their wastewater after the nickel recycling process. Average is about, it's below 0.5 ppm, so it meets most the regulation in most countries right now. So above is my presentation for today, and thank you for your attention. Thank you.
Okay, thank you for the sharing from Mr. Hong. And thanks for the great sharings from our lecturers today. Let's take a short break. There are other topics coming up. We will be right back. Hello everyone, welcome back. Please welcome General Manager of展欣Environmental Engineering to share with us about green technology in metal surface treatment industry, recycling and carry out trash reduction, and also Dr. Austin Xu as the interpreter for us. Welcome, Mr. Alex Zhao.
Hello, everyone, and good afternoon. 大家好。今天很荣幸有这个机会跟各位介绍金属表面处理业与绿色技术的制程应用回收的一个减废的应用分享。
Today, I'm so glad to introduce you green technology in metal surface treatment industry, recycling and carry out trash reduction.
首先为各位介绍我们一般电镀业的制程有分前处理制程的部分有脱脂、粗化、穿洗，还有活化。那电镀制程后面的有分电镀之后的皮膜处理、干燥这些制程。
As you are familiar with the process of plating, we can have a raw product input and must go through degrees, acid rinsing, and surface plating, and dry, and then we have finished good product. And during this process, we will generate amount of wastewater.
它的前处理的表面处理制程里面呢，包含了酸洗、水洗，还有脱脂这个部分。
In the pre-treatment, we need to go through degrees, acid rinsing, and activation process.
那表面电镀之后的综合电镀、水洗，然后再来酸洗，最后电镀完之后的干燥。
And after pre-treatment, we need to go through a different kind of metal plating or surface treatment process, and then dry and clean.
谢谢。接下来为各位介绍一下我们电镀这些技术里面一些控制条件和影响的因素有我们的电流的分布pH 值电极的材质导电度等等这些控制条件及会影响到产品的一些因素。
We know that there are several parameters very critical to plating, such as current and the chemical homogeneous and pH value and the material of the anode, all affecting our plating quality.
在也跟各位分享一下，过去我们电镀的程序里面最喜欢用的一个用水的习惯做一个分析过去来讲，我们习惯性的是用平行的清洗法，我们随着镀件的移动方向，我们的水洗的方向也跟着镀件的移动方向来进行这个缺点容易导致我们的水量大。
And traditionally, that when we process the cleaning process, the cleaning flow is parallel to the processing flow, such as you need to input rinsing water from beginning and follow through to the end. And in this way, we call parallel rinsing. That in this way will generate a huge amount of wastewater.
是的。那我们先从制程来做一个改革先把它改为逆向的一个清洗法。随着镀件的方向，我们的水洗的方向是从跟我们的镀件移动方向是反方向的来进行这样的好处是我们的水量少可以少到很多。
And here we propose a new method of rinsing. We call reverse rinsing. That will input water from back end to the front. So in this way, you can reduce big amount of wastewater.
是的，那依据我们的经验跟统计分析，我们过去来讲，一般的电镀厂可以经过逆向的是一个清洗的方式，可以节省水量一年可以节省了16500吨的一个水量，那节省的台币大概107万每年。
And in practical activation that we evaluate every year, if you use reverse rinsing, that you can save about 16,500 tons water per year, and you save almost 1 million NT per year.
是的。那如果我们用假设我们用一段清洗水量是100为一个基准，那我们用2段式，我们可以省掉90%，只剩下10% 的一个清洗水量。那如果我们用到3段的一个逆流的清洗水，那我们可以节水达到95%以上，只剩下4.6% 的用水量，而且不影响到我们的清洗的品质。
If you separate the rinsing section, if you have only one part of the rinsing process in reverse, you can save like 100 tons per year, 100% per year.
接下来从我们的废水的来源跟各位做一个分享跟介绍。我们废水来源常常有分2个系统，一个是废液的，那它的特性是量少浓度高。那清洗废水的部分是量多浓度低。
The wastewater comes from 2 kind of source. One is from the plating chemical itself, and one is from the rinsing water itself.
是的。那以电镀废水来看的话，我们常见的有氢系、弱系，还有镍系，还有酸碱这几股废水。我们如果做适合的分流处理进到废水处理系统这样子比较容易达到我们的法规的放流水的标准。
Generally, you have cyanide wastewater and chromic acid wastewater, and the other plating chemical wastewater. If you can separate this kind of resource in different pipe, you can have easy treatment and better management for the wastewater.
那接下来为各位介绍一下，一般我们废水的一个处理的技术常见到的酸碱废水的部分，我们常会遇到化学混离沉淀法、离子交换树脂法、活性炭吸附法、薄膜处理法，还有磁分法。
In general, if you want to handle the acid or alkaline wastewater, you usually use resin exchange, ion exchange method or RO method, or a chemical sediment method.
是的，谢谢。还有我们常见的各镀镍的一个废水，我们常用的方法有还原混离沉淀法，还有离子交换树脂，还有我们的细藻土的一个吸附法。
And for chromic nickel waste system, you either use ion exchange resin or use a special chemical recover sediment method.
具毒性比较高的氢气废水，我们也常常看到的有氧化混离沉淀法、湿式氧化法，还有电解氧化法，还有碱氯的一个氧化的一个处理方式。
For cyanide wastewater, you can also use ionization or some mixing sediment treatment method.
那也跟各位分享一下我们常看到的一个废水的处理流程。氢气的废水，我们常常会经过第1氧化跟第2氧化。那还原的弱系的部分，我们会先行处理一个还原反应的一个处理，最后才合并到酸碱废水一起做化学混离的一个沉淀。
Okay. For cyanide waste, usually go through 2 processes, first oxidation and second oxidation.
那最后我们的沉淀的污泥再来做一个脱水减量最后污泥来委托合法的清运业者来清运。
Then after the final step, you have mixing solid waste, and you need to contract this for outside treatment.
是的，在这里也跟各位分享我们的弱酸的一个回收的一个方式怎么如何的浓缩及纯化跟各位先介绍一个弱酸的一个大气浓缩及纯化的一个方式。
Here we give you an example for chromic acid waste system. We developed this our special treatment method. We call it air exposure concentration method.
我们会将在弱酸镀槽之后建置3个回收槽之后再把回收1的浓度比较高的水洗水拉到我们的大气浓缩的设备里面蒸发提浓到最后再回补到我们的镀铬的弱酸回收弱酸的一个使用。
For example, we will have 3 tanks to collect the chromic acid waste, and we will have first one pipe to the concentration tank, and through our special design, we increase the air exposure service, and we concentrate the waste, and then we can piping back to the chemical plating chemical tank to reuse it.
这是我们比较常见的，我们在现场有看到的一些设备的一个照片，跟各位分享。
Okay, this is real equipment we install in a plating line.
但是它也有相对的一个优缺点，它的优点有那个废水药剂的减量，还有污泥的可以减量大量的减少了含弱废水的一个污泥产生，还有可以资源的再生，将6价铬的浓缩回补到我们的镀槽去。但是缺点是操作条件比一般的废水系统来的复杂，那能源需要提供热能给它加热，那维护费用稍微多了一点，因为它需要损耗及定期更换它的加热设备。
Here are the advantage that you can reduce your waste treatment chemical, and you can reduce the solid waste, and then after you collect the concentrate chromic acid, you can pipe it back for reuse. But the disadvantage is that the cost is higher because you need to generate the heat, and the maintenance cost is also higher.
也跟各位分享一下另外一种回收的方式，是离子交换法的一个离子交换系统一个方式。经过我们各水洗妥善的收集之后，经过我们的离子交换系统，然后可以把浓度提高将干净的水回补到水洗，那浓度高的再生液回补到镀槽这是我们一般常见的一个流程图。
And here we also have another alternative. We use ion exchange tank to collect different rinsing water from different process. Then the other way, we concentrate the waste water and reduce the amount of waste water. Then we have clean water and then can pipe back for reuse.
这样的系统在常常看到在镀镍的系统、镀黄铜的系统，还有重铬酸钾的一个皮膜制成里面常见到的一个回收处理的流程。
And we can use this for copper plating, chromic plating.
OK， 重铬酸钾的。接下来为各位介绍一个比较常见的一个镍回收的一个方式，就是以离子交换的一个系统来做一个回收。我们设备我们的水洗水经过我们的活性炭吸附有机物之后经过2个阳离子1个阴离子做一个妥善的一个过滤吸附把浓度高的再生液回补到制成，然后阴离子出来的循环水可以回补到现场循环再利用。
Okay, here for nickel plating, we design a recycle system. We install several ion exchange tank. We collect the rinsing water or waste, chemical waste, and we can concentrate the nickel concentration, and we can pipe it back for reuse. And the other way, we will get more cleaning water, and we can reuse the water.
是的。这一部分也跟各位介绍一下，在目前比较新颖的一个回收方式是膜的一个回收、过滤及浓缩一个流程。
And we use a special membrane for recovering the nickel, and this is a new technology.
我们将水洗水之后经过回收槽，然后我们经过我们的RO 来做一个妥善的一个过滤，过滤完之后产出的干净的水回补到制成水洗水使用。那再经过第二道 RO 把那个浓缩的水提得越浓越浓度越高，到最后用海氮的膜去把它特殊过滤，让这些浓度高的水可以回到镀镍槽去使用。那陆陆续续产出来的干净的 RO 逆渗透水可以回补到制成做清洗最有效率的一个清洗的方式。
This is for nickel plating process. We install the membrane in the recovering system, and we can collect the rinsing water, and then after the membrane, we'll get more cleaning water. Then we can pipe it back for reuse. And the other way, for high concentration wastewater, we can go through another membrane to have more concentrate water, and then this chemical we can also pipe back for reuse.
是的。再来跟各位分享铜回收也常见到的一个离子交换法的一个流程这跟刚刚的一个镍的回收是相同的一个方式。
For copper plating line, we can also use the same technology and idea to recover the copper in the line.
那过去我们在铬的回收上也常常用离子交换法来做一个回收的流程这个也是跟我们刚刚提到的离子交换的一个镍的回收有同样的一个方式这样子的流程图。
For chrome plating, we can also use the same idea, use the ion exchange process to recover the metal.
这个是我们在现场所看到现场使用的一个照片那个在过去在现在这个是回收膜的一个浓缩法的一些设备照片第一张图是前处理的一个单元，先做初步的过滤第二个是 RO 加海氮膜最后的镍浓缩液回补到制成。
This is for nickel plating. We use the special membrane to collect the water through RO, and after the membrane, we can have reused wastewater.
它也有相对的优点跟缺点那优点的部分RO 的残水可以循环回补到水洗槽，那大幅减少含镍的污泥产生资源的再生有硫酸镍和盐化镍的一个浓缩回补但是缺点的部分是技术门槛也比较高操作条件比较复杂，那动力的费用比较多维护的成本也稍高了一点，因为有一些固定的滤材必须清洗或更换。
For this membrane recycling process, there are some advantages. For example, you can reuse the water after the RO filtration, and then you can reduce the solid waste, and you can use the concentrate chemical after the membrane. But the disadvantage is that the technology is not is sophisticated. It needs more operation attention, and you need more power to push through the membrane, and then the maintenance cost is also higher.
但是相对的，它这个部分的分离技术越来越成熟所以是广泛的在使用中。
But the membrane technology is mature and it is widely used right now.
这是我们在最后也要搭配到我们适合的一些水量的控管，还有一些精密仪器的控制，这样才能让我们的回收技术达到最好的一个效率跟分享。
For better recycle management, you also need to pay attention to the control of the water the water system. Also, you need to have more sophisticated control system and monitor system.
接下来为各位介绍一下初步的介绍国家越来越先进对于氨氮的一个处理要求越来越高，这是我们目前比较常见到的一些回收处理技术稍微给各位看一下。
We also develop nitrogen ammonium waste recycle system, and if you are interested, we can provide information to you.
最后要跟各位分享的是在环保法令和制程的改革要同时的进行产生一个清洁生产的一个制程，这也是我们台湾的电镀业目前一直在往正确的发展的方向。
And as India, Taiwan also have more and more strict environment criteria, and we need to catch up and improve our manufacturing quality. And we also spend a lot of effort to study and develop new technology for it.
从我们制程的改善方向里面有包含了我们的使用的化学药剂不要超量，我们的维持最高的一个容许的温度，然后各个电镀槽润洗槽之间装置沉滴板不交叉污染，每一阶段的充分清洗，避免一个交叉的污染然后调整镀件加速排流，改善设计也加速排流，让这些润湿剂改善我们的清洗效率，减缓镀件从镀槽中提起的速度，滚镀的时候也注意要转动滚筒的速度。
There are a lot of small details that you need to pay attention. Like when you use chemical, you need to use specific amount. You cannot use more than the required, and you have to maintain accurate temperature, and you have to collect a lot of chemical in order to protect your machine and the environment. And also you need to pay attention for the rinsing process. You cannot contaminate each other, such that there are so more details you need to pay attention to.
最后要检讨我们的合理的用水性深入去了解各个生产单元检讨它可行性的一个用水的一个改善方式，然后再回收带出的镀液减少清洗的用水量，那改变一个平行的清洗法，改为逆向的清洗法。那用逆向的清洗法利用自然的顺流、喷流、注射空气等方式，让它减少的镀液的带出，减少适当的利用水回收系统，妥善的利用有限的资源。
We suggest that for the waste reduction, you need to pay attention the water waste, because the water waste is very critical for plating, and the more details that you need to pay attention to the dripping after your plating parts come out the tank. You need to avoid the liquid waste, and then you have to change the traditional parallel rinsing process to the reverse rinsing process as we proposed, and you have to pay attention to the airflow in order to save the water, and you need to select correct waste treatment equipment in order to have very effective waste management.
最后我们也希望说和在执行这些相关的回收技术和设备，不但能够有效的回收有用的原料，更能降低废水污染的浓度和清洗水量，可以达到电镀工厂的一个制程减费、降低生产成本的一个理想设施。
When we talk about waste treatment, it's not only waste treatment. You want to reduce your cost, and also reduce the amount of waste, and also you want to improve your manufacturing efficiency, and all this. Not only waste reduction, you need to improve everything.
在这样虽然我们都处于整体严峻的一个经营环境之下， 那产业也往往需要承受比较高的一个物价的成本。我们现在的环保法令又越来越严格，那我们也会步步的为营希望因此我们的政府和产业要密切的合作让我们业者能够用心的经营，爱护环境永续的来经营。
Our customer is facing a very harsh environment. Also, the material cost is getting higher, and so we need to work together with government and some specialists to work to solve the problem.
Thank you.
Thank you for your attention.
Okay, thanks to Mr. Alex Zhao for the very informative sharing, and also great thanks to Dr. Austin Xu for the interpretation. Okay, before starting our last topic, let's take a short break. We'll be right back. Hello everyone, welcome back. Coming up next is our last topic for today. And please welcome Dr. Yaru Zhuang from Industrial Technology Research Institute. The topic she is going to share with us is sustainable water treatment solutions and low-impact ZLD, MLD processes. Please welcome Dr. Zhuang.
Hello everyone, namaste. Yeah, this is Anne from Yichi, Taiwan, and today I would like to give a brief introduction about the sustainable water treatment solutions on the low impact zero liquid discharge or the minimized liquid discharge process, especially in the case of the metal surface treatment industry. Okay, and let me briefly introduce about Yichi's water technology. That Yichi's water technology have developed a set of water technology with high efficiency, low energy consumption with affordable prices. And in recent years, the aim of Yichi's water team have changed from the compliance of environmental legislations to the water and resource reclamations. So from this picture, we can see that Yichi's technology can be applied from the upstream to downstream, such as the seawater desalination, the industrial wastewater treatment and reclamation, and the municipal water treatment, as well as the decentralized wastewater treatments. So Yichi have a variety of technologies, such as the biological, the physical chemical process, as well as the advanced process and the sludge reduction. And all of these technology we already apply in many fields, like the fermentation, dye, textile, the metal surface industry, papers, leathers, and some high technologies. So Yichi's water team shows the capability not only in the systematic design, the engineering design, as well as the integration of competitive water solutions. And not only in the application in domestic practical practice, such as the high-tech, the traditional industrial, as well as the government projects. We also have many cases and many clients around the world, like Singapore, the mainland China, Indonesia, as well as India. Okay, so first let me talk about the low-impact wastewater treatment for the metal surface treatment industry. In the metal surface finish industry, which is comprised with a large variety of activities, and the purpose are mainly focused on the treatment of metal surface, the protection of the corrosion, to improve the resistance to wear and erosion, as well as the appearance enhancement with the metallic coatings. And all of these activities have been divided into two main treatment categories. The first is the cleaning process and the surface pretreatment, such as the alkaline cleaning and some other process. And the second stage will be the metallic coating and the finish, surface finish, like the electroplating, electroless plating, and anodization, as well as the chromate conversions. And from this process, I think a lot of amount of the wastewater with diversity composition will be produced. And as we know that the wastewater treatment process is mainly depends on the composition of the effluent or the environmental need or the objective of each company, such as in some places the company have to meet the requirement of the zero liquid discharge, or some of the company would like to increase the water recovery rate or adjust some kind of the wastewater effluent until they meet the requirement of the effluent standards. So to achieve the low impact wastewater treatment, that the treatment system have to be designed for maximizing the freshwater recovery. It means that we have to increase the recovery rate or to reduce the volume of the brine or the final waste disposal products. And here in this slide shows the general process of metal finish process. The first stage will be the preparation, the pretreatment of the surface. And the second stage will be the surface treatment. And in all of the process, which will produce large amount of the waste, which from the rainwater effluent from the plating base, some of them will be the surfactant or from the strippers. And unfortunately, most of them are non-biodegradable because which consist of the persistent bioaccumulative toxic substance such as the heavy metal, the cadmium, chromium, and even the cyanide. So in the effluent water quality, which are always with very high COD value and extremely pH value and high organic compound, organic contents as well as the TDS. So let's talk about the water qualities. I think in most of the process that the inlet water quality plays an important role, not only in the final product qualities, but also in the recovery or the recycling technologies. So to the elimination of the planting contaminants plays very important roles. And here I would like to suggest some pre-treatment process of the inlet water quality. The first would be the ion exchange resins. The second would be the RO system, which we call is reverse osmosis. And in most of the case, we will think about the cost assessment, and we normally suggest that if your inlet water quality is higher than 500 milligrams per liter, that the RO system will be more cost effective. Okay, and as for the recycling technology for metal surface treatment, waste, we always say that by the combination of proper technology that it is possible to accomplish the zero liquid discharge to the following sewage or the following stream system. Means that we can try to reduce most of the final product, most of the waste to the environment. So by applying the proper process, the finisher means that we can have more profitable resource recovery, such as by the recovering of the process solution and reuse it and send back to their tanks, or to remove the pollutants or the impurities from the process solution, which can largely extend the lifespan of your solutions, or to recover the metals or the resource, valuable resource like heavy metals, which can be reused again or sent back to the supplier. So here I would like to share this process, as we know that in most of the wastewater treatment plants, the wastewater once produced from the industrial sectors, they probably have to be first pre-treated by the physical or chemical process. And afterward, if you want to recycle the waters, you must have to buy the reclamation system like the membrane filtration process, such as the RO system and ultrafiltration process. And in this process, the clean water will produce. Meanwhile, a brine will also be produced, which have to be treated by the thermal process. And as we know that thermal process is with very high OPEX. The operational expense is not generally quite high. It's around more than $10 per cubic meters. So if we want to overcome this kind of issue, that we have to think about the brine reduction to reduce the need of the thermal system, as well as the refractory organic decomposition. So here I would like to suggest some low impact wastewater treatment process. The first thing is the electrodialysis reversal. We call it EDR system. And the second one would be the phantom process for the organic decomposition. So the first thing is the ED or EDR technology. The ED, we call it electrodialysis, which composed by the electrical charge with the selective membrane to separate ions from the solution. It means that we can get the clean water, which is deionized. And the EDR system, we call it electrodialysis reversal, which is an advanced version of the ED system and can periodically reverse the polarity of the electrode. And this can prevent the scaling or the falling of the membrane or the electrode system and to extend the lifespan of the EDR system. Okay, so the EDR system shows some features like the water softening without chemical addition, because we only separate the ion by electrical charge. So you can remove the ions from the solution. So this is capable for treating the lower grade effluent compared to the RO system. So this can be used for the RO brine reconcentration to reduce the brine. So therefore we can obtain much higher water recovery rate with high desalination efficiency. So here shows one of the case we installed in India's CETP. And this CETP is one of the zero liquid discharge CETP. And in this plan, they meet some urgent issue about how to increase the water recovery rate because the too high loading of the evaporator, which caused the lower recovery rate and high energy consumption. So in this case, we installed the EDR for treatment of the RO brine. And after the installation, we can see that the brine, we can easily reduce the brine for at least 60%. It means that in the full-scale plant, that we can save the OPEX at least 3 quarts ruby per cubic meters in a year about the OPEX of the thermal system. And in this slide shows the EDR application in many different fields of the industrial process waters, not only in the desalination of groundwater seawaters, we also apply in some electroplating company or some high semiconductor manufacturing corporations. And the next technology I would like to share is the Fenton process, which can be applied for remove or decompose the refractory organics. So Fenton process, as we know, which is an advanced oxidation process, we call it a kind of AOP, and which by applying the Fenton reagent, we call like the hydrogen peroxide with the ferrous iron to inside generate the OH radical for the organic decomposition. And I think some of the people know about that Fenton have made at least 4 kind of the series. And I would like to suggest 2 of them. The first is the ferrofenton for the high strength wastewater treatment. And the second will be the FBR Fenton for treat the residual organics, which for the polishing of the effluent water qualities. So the Fenton process shows some features which to enhance the pollutant biodegradation rate and to decolorize and with very small footprint and easy to control. So the Fenton process which we would like to apply are mostly in the refractory organic wastewater treatment or to decolorize the wastewater or to remove the surfactant, especially in finishing the dye, PET fibers, PCB companies, and all these kind of effluent which can be treated by the Fenton process. Okay, so in this table we can see that we have each already have many cases by the installation of the Fenton process. So the Fenton process is capable for use for the high COD value decomposition with high COD removal rate. And here I would like to make a brief summary about my presentations. The low impact water treatment process can be improved by many ways, like the previous speakers mentioned, that just like use the least toxic or easiest way to manage the chemical. And the second would be to extract the most used chemical or material and reuse them in the process. Means that keep the chemicals where they belong in each tanks. And the second would be use the least amount of the wastewater for saving waters. So due to many reasons like more stricter environmental legislation, more the water scarcity issue or the high OPEX of the wastewater treatment process, the novel and a proper technology for water management and treatment are the urgent issue. So I would like to say that if you want to have a more low impact water treatment process, there are 2 issues you have to consider. The first is to improve the reuse water quality by the proper technology. And the second one is try to reduce the need of the thermal system, means that you can use different reconcentration technology to reduce the brine and enhance the recovery rate of the fresh waters. So here are all my presentation, and if you are interested about Ichi's water technology, you can Google search the Ichi waters. And thank you for your presentation.
Okay, thank you, Dr. Zhang, for the great sharings. And since now we are having our distinguished guest coming up next to conclude the forum for today, let's have a 1 minute break and we'll be back. Hi everyone, today's forum is coming to the end and we feel privileged to have Dr. Austin Xu to conclude the forum for us today.
Thank you, Alex, for your hosting. And I would like to express our sincere thanks to Jennifer in India to organize this webinar, and also our friends from EMFA. And we start a new relationship right now, so we decide to grow it together, and we look forward to more cooperation in the future. And also I would like to thank Dr. Wu from MIRDC and Dr. Zheng from ITRI and Phoebe Chen from CNFI to help us to organize this nice webinar. And also I would like to express my sincere thanks to our wonderful speaker. The first speaker is from Mr. Zhao from展欣environment industry, and Mr. Hong from Rich Fine Chemical, okay, and also Dr. Zhuang from ITRI, and also a speaker from Atotech to help us to present very valuable material. And we hope in the future we have more webinars together to exchange ideas. And we not only look forward to technology exchange, we look forward to more business exchange and grow together. Thank you for everyone. Thank you.
Okay, great thanks to Dr. Xu to conclude the forum for us today. In the end, I would like to thank everyone for sharing their time today. Any feedback would be valuable, so please feel free if you want to leave any message to our email address. Thank you for your time and attention for today. I'm Jason Wang, and we hope to see you soon. Goodbye.